Welcome to our next lesson in our sequence, where we're going to look a bit more about rates of reaction and get ready for our experiment that's coming up shortly. There's a few things you're going to need to put together for it, so be looking for those bits. So first thing, have a think, what did we actually discuss last time? Take a moment to have a think about what it was that we did last lesson. You recall we were talking about rates of reaction. We talked about 4 different factors that can control a rate of reaction, how quickly that reaction goes. See if you can recall those. Today's objectives, we're going to review the factors that affect reaction rates in just a minute, and that's the question I just asked you on the last slide, so I hope you thought about it. Revise the importance of why we control our variables, and prepare for our experiment, investigating the factors that affect reaction rates between antacid tablets and vinegar. And they're the things that you're going to need to find around your house somewhere. So first task, I've got a little video there for you. Go and check that one out and see how you have a go with that one, and we'll be back shortly. So this is the work we did last time. What are some ways in which the rates of reaction can be increased? There were 4 ways, and that's what I've asked you this a couple of times in this video. What are the 4 ways we affect the rate of reaction? There is temperature, and the question is, how can the rate of reaction be increased? If we increase the temperature, we will increase the rate of reaction. There is concentration, and once again, if we increase the concentration of our reactants, there's more of them to physically collide with each other in our collision model, hence the reaction will run quicker. There is surface area. That little A with a little subscript S is a symbol for a surface area, and I wrote it out there for you in full in the brackets. How can surface area increase the rate of reaction? If we increase the surface area of our reactants by usually breaking them into smaller pieces, split wood into smaller bits of wood, break up clumps into smaller particles, and if you keep breaking it up, you end up with a very, very fine powder. That will increase the surface area, hence the rate of reaction can increase. And the last way was adding a catalyst. A catalyst is a chemical that we add to the reaction. It's not used up in the chemical reaction, but it makes the reaction run faster. Think of a catalytic converter in your car. It does exactly that by converting some of your car exhausts into slightly less damaging substances. So we're looking at indigestion. Indigestion is where you get that burning pain in your stomach. And this is an example of a reaction that people want to control. Indigestion is basically you've eaten too much sort of rich and spicy sort of foods and things like that. And essentially you've got a bit too much stomach acid, and it wants to sort of start coming back up out of your stomach, back into your sort of esophagus and up towards your mouth. And you feel it as what people call sort of heartburn, because it affects around near where your heart is in your chest, as that acid sort of almost leaks its way back up towards your mouth. So what we do is we take a tablet called an antacid, which is sort of like an anti-acid. It's usually a substance that's an opposite of an acid, such as a base, to try and neutralize that acid and get the relief from that heartburn feeling. So this week we'll be doing an experiment to investigate the factors that affect the rate of reaction. And what we're specifically doing is using an antacid tablet. You will need to find those, and vinegar. Most houses have vinegar under the cupboard or something like that. The vinegar is just like a weak version of the hydrochloric acid that's in your stomach, and we're using the vinegar to model your stomach acid. So the vinegar is representing the hydrochloric acid, but that's a very, very strong acid, and you don't really need to use a strong acid to see the reaction with our antacid. So, as I said, antacid will neutralize our gastric acid or our stomach acid to reduce pain. You can kind of think of most of these reactions as a bit like the neutralization is essentially there's an acid in your stomach, that's hydrochloric acid. You add to it the opposite of an acid, which is a base. And when they react, they kind of cancel each other out because they're opposites of each other. and you end up getting a salt and water. And that's what they produce. It's like the acid's got a lot of hydrogen atoms in it, which becomes the hydrogen in the water. And a salt is just the name of a group of chemicals that we have in chemistry. The most common one's obviously table salt, but it's just a far less harmless chemical than the acid that was in your stomach, sort of causing that heartburn. And that's this point here. The antacid reacts with the acid, forming a new product which is not acidic. Water is totally normal, makes up, 70 or 80% of your body. And salt, you have that in your diet anyway, and it's not generally a harmful product unless you've got too much of it. But in this case, you won't. Generally, it's about 3 to 5 minutes until the neutralisation occurs and you start to feel better. But what's happened is this reaction has occurred and there is no more acid causing that heartburn. Many antacids, it's a tablet, so it's mostly just a mass of stuff that you can swallow, but the actual active ingredient is this some sort of hydroxide, which is usually a basic or a base compound. So carbonate, bicarb, something like that. If you can't find antacid tablets in your house, you've probably in the cupboard got some cooking stuff, some bicarbonate or some sort of carbonate type substance that your parents might use in cooking. That will take the place. And down the bottom here, the carbonates will produce an acetate, which is one of these salts. Usually there's a bit of carbon dioxide in these reactions that occur, and there's water. So sometimes that reaction at the top has a few extra things. In this case, you'll get a bit of carbon dioxide, which may go right through your intestines, or it may come out as a burp or something like that. Now, when we're investigating the factors, we want to think about those things that impact on our rate of reaction. So we're going to model the gastric acid, the hydrochloric acid in your stomach, using vinegar. You can use an antacid to react with it. So you want to think about how you're going to have that vinegar at different temperatures, at different concentrations, at different surface areas, and the catalyst doesn't really come into this one. So we're going to really look at those ones. Here's the chemical equation of what's actually going on. So all antacids will react with vinegar to form water, and acetate, which is that salt, and carbon dioxide, that gas. The reaction that we've got is vinegar, which is acetic acid, and antacid, which is calcium carbonate. What we've essentially got is this as a word equation or as an actual chemical equation. The calcium carbonate plus acetic acid, which is vinegar, what we call vinegar, you will get calcium acetate, and that acetate bit came from the acetic acid. The calcium bit came from the calcium carbonate. You get a bit of carbon dioxide and a bit of water, and that's the leftover stuff after that salt was produced. So what we're going to have to do next lesson, this is just letting you know what's coming. You're going to have to do a quick write-up on this. You'll need obviously a title, something along what's listed there. You want a name. Find out if increasing the temperature, concentration, and surface area will have any effect on the rate of reaction. The hypothesis is, what do you think? I think that an increase of temperature will increase the rate of reaction. I will see this because it will bubble quicker, something like that. And then you do the same for concentration and surface area. You'll need to pull together these things. Get yourself a ruler, some sort of markery pen. When it says empty bottle, just like an empty Coke bottle or plastic bottle, one of those disposable ones that you can take to the 10-cent recycling things, or one of those is all you need. You probably want some scissors. You're going to have to record the time of your reaction that it occurs, so you need a stopwatch. Any sort of vinegar that you can find at home will work, and any sort of antacid tablets. If you don't have that, you're going to have to try and find some bicarb or something like that in your cupboard at home. And having some protective gear is always a good idea when you're doing these sorts of reactions. These are general household items, so you probably won't need gloves or anything like that. But things like safety glasses or something are always a good idea. Here's our method. You put on your protective gear, cut off the top of your water bottle to the first line, fill it with vinegar to that line on your container. I'll show you a video of this. In our OneDrive, we have 4 videos saved that have this prac, and we show you the actual steps that you've got to go through. So you need to go and check those and watch them as well. You want to record the level that your vinegar's at, put in an antacid tablet, and then start timing. And what you want to do is mark off how high up it's going to foam. Because if you've got your Coke bottle like this, for example, you have your vinegar up to there, so there's your vinegar. You get your antacid tablet and drop it in, and what it's going to do is start foaming up. So it'll foam up the bottle, and that's the reaction, the neutralisation reaction of your antacid and your vinegar. You want to record where does that go to in your bottle. You also want to time it, how long it takes to get to the top. So you record height and time it took to reach its maximum height in your bottle. Wash it out, dry it out, and you can try it again. Okay. Here's a little table to help you. This is basically your results table. You look at surface area. You want a whole tablet and crushed up tablet. If you can only find bicarbonate or something in your cupboard and that's powdered form, see if you can try and sort of squeeze it together, compress it a little bit to sort of make a tablet, because that's effectively how tablets are made. You want to have a look at temperature, so you can get some of the vinegar, for example, leave it at room temperature, get another bit, put it in the fridge for half an hour or an hour so it gets really cold, see how that affects the rate of reaction. Failing that, you could use some ice cubes or something, but it's not really going to be the same sort of thing because the ice is going to dilute the vinegar a little bit. And you want to look at the concentration. So have just straight vinegar, which is there's no water added, and then dilute your vinegar. So when you've got your container, if you're filling the vinegar up to this level the whole time, when you do this last one, you don't need to fill the vinegar up halfway, and then the rest of the way you add water. Here's an idea of the data analysis you've got to do. All right, so you'll have to do an analysis section, and that's your analysis bit, and do a conclusion. So when you do your analysis, what are your trends in your data? Is there a relationship that you've seen? Is your hypothesis supported? Write yourself a conclusion, which is just a nice little paragraph to summarize what you did. Okay, was there any changes? Did everything work as you expected? Did the temperature, concentration, surface area change the rate of reaction? And obviously think about, was there any sort of uncertainty, some error, some problem with your experiment, some way it can be improved, things like that. Okay, so you might want a little bit of text on that one. Don't try and squeeze it all into one single paragraph. You want at least 2 paragraphs there, minimum. See how you go. All right, that brings us to the end. So next time we'll have a look at the experiment a little bit more closely, and we'll take it from there. Thanks for coming.